Sonic, Malik, can you close the blind? I think it's a little bright. Whoa. Great. Have you all read it? Yeah. I don't think there's any word in it that's difficult. What you have here is the temperature of a cup of coffee. Oh. It's really funny, but the only time this doesn't want to work is exactly this class. Well, yeah, well, I mean, there's no reason. I can't do anything special. It's the same. Let me. Maybe it is haunted. Okay. I think we're good. We're good. Okay. Yeah, I got Ghostbusters on it. Right. So the temperature, theta for temperature, is equal to 27 plus K e power minus 0.2 T. The K and the T, the K is a constant, and we don't know what value this constant is. But the question says the initial temperature is 65. So can anybody tell me the meaning of this word? Yeah, well, firstly, what does this word mean? At the beginning. Yeah. And as you said, what do you do?
Substitute T.
Yeah. Substitute this in for theta, but what do we make the T? 0. Because it's at the beginning. So you have 65 equals 27 plus KE0. So 65 minus 27. What's that now? Right, so you got K equals, therefore K equals 38. Right, so now you have theta equals 27 plus K, not plus K, plus 38 E minus 0.2 T. Fix the colors a bit. Okay, that's okay, I hope. Now the B part is more interesting. I want to know how long until the temperature is 35. So I want to know when will the temperature equal 35. I guess we'll have to do. Okay, any ideas here? Make the theta 35.
And then use log.
Yeah, we'll need to use log. Not at first, but we will need to use log to find the time. So if I bring the 27 over here, I get 8, don't I? What should I do next?
Logging both sides.
Not quite yet. Yeah, bring the 38 down first. So I get 0.210526, etc. equals e power minus 0.2t. Now, log on both sides. So I put a log here and a log here. But the log will cancel the e on the right. We saw that last time. So on the left, I get minus 1.558 equals minus 0.2 t. Yeah, and then divide. So the t is about 8 minutes. Yep. Okay, can you just read number 2 and then I'll do number 2. Okay, let's have a look at it. Have you done interest with Donal or with Mark? No. But you know this word, do you? Yeah? So, when you put money in the bank, it will slowly grow. Yeah? Now, in fact, I mean, you could think about it as a graph as well. Money, time, more money. Also more problems. But more time, more money. And the shape of the graph is actually exponential. That the amount of money you have is from this formula. Now this is only true if you don't put more money in. If you just put some money in and then leave it, it will increase this way. So of course what we would like to know is what is the A and what is the K. Okay, so if I go to the question now, you're told at B, the balance is equal to AEKT, and T is in days, and at the start of the year, the balance is £100. And then at the end of the year, the balance is £103. So at the beginning, the time is 0, and at the end, 365. This is enough information to find the A and the K. If you think about it, when we had a straight line, you need 2 points. And likewise here, even though it's a curve, you only need 2 points to find the A and the K. So if I put this in first, I'll get £100 equals AE0. So what does the A equal? We can all see it's 100, yeah? So now I have B equals 100 EKT.
Excuse me?
Yeah.
But like this kind of question is little bit confusing because the number of days change over the 4 years.
True. I was just thinking that when I said it because this year, 2016, is 366 days. Yeah. So I think in the exam they'll be a little clearer. Yeah. So I think they'll make it a bit clearer in the exam. Yeah. Although, if you use 366, the answer will be so close, it will probably be the same. Anyways, yeah. Okay, so now we put this point in, and you get 103 equals 100 E 365K. So what should I do to try and solve this first? Divide by 100. 1.03 equals E power 365K. And then log. So I get log 1.03 will be 0.029559 equals 365K. So I get K equals a very small number, 0.0008098. So I'll go with 81 just. So I have my answer. Your balance will equal 100 E power 0.000081 T. So I just want to nicely draw that for you. 100 E power 0.000081 T, or X here because the graph. So you can see that for the first 4 days, your balance doesn't really change. So if I look on a different level, so after a week, still looking pretty flat. Still not looking good. It's only 3%, and it's only a week.
For
yeah.
the whole year.
For the whole year, yeah, exactly. Now we're getting kind of closer. So here is 1 year, and you can see it's slowly increasing. Maybe if I zoom in a bit, it might help. No. Okay. Oops, wrong way. Right. Now let's see. What's that? That's going to be like maybe about 4 or 5 years. And now see. Now we're talking. So 10 years would be 3,000, nearly 4,000. So this would be after 10 years. And that looks much better. Although you'll probably be dead about then. So 3%. It's not great. It's not great. 3% is kind of a normal amount for banks. Yeah, not great. And anyways, you also know about something called inflation. Yeah?
Yes.
What's an usual percentage for inflation?
1 point something.
Yeah, what's the European Central Bank goal for inflation? What percentage would they like it at? Does anyone know this? ECB? You know the ECB? Oh, you don't? You didn't do this in economics? European Central Bank. Have you done central banks? Have we done banks? No. Okay. Well, in Europe, the target of inflation is 2%. This is the target, the goal. So if you have, huh? It's high in Brazil at the moment, isn't it? Is it 12%? Wow.
Because
That's not
it
cool.
depends, I think, for the economic growth.
Oh yeah, there's many factors for it, yeah. In Ireland, I think it's at the moment about 0 for the moment. It's not much. It's about 0. What's it like, Saudi, isn't it?
No, Oman.
No. Oman. What's it like in Oman?
I think 5 or more, something like that.
It's kind of high then.
Yeah.
Yeah. And what's it like in China? Do you know? No idea? Don't know? Nigeria, would you know? It's very high, like for you as well. So if you're only getting 3%, but inflation is 2%, then really how much are you getting? It's only like 1%. So your graph is even worse than this. Okay? Alright, the next part. After half a year, how much will be in the bank? So, what should I put in for the time? After another half a year. So what's the time? Half of 365? Not quite. It's 365 plus 365, yeah, over 2. I said after another half a year. So if we just take this number and put it in, it'll probably be like 105 or 104 or something small still. Yeah, that's not much. So you get a balance of £104 and 53p.
This is good for a loan.
3% would be great if you had to get a loan, yes. But if you have to save money, it's not so great. The interest rate at the European Central Bank, I think, is 1%.
For loans?
For loans to governments or to other banks, I mean. And then I think in America, the interest rate for the American Central Bank is not even 1%. It's 0.25%. Yeah. And of course the reason for this is, why are the interest rates so low? Does anyone know?
To
Yes?
support the economic
That's
growth.
it, yeah. If the interest rate is low, then it stops people from saving money. So it means it forces people to spend money. Also, if the interest rate is low, it means it's cheaper to get a loan.
But
Yeah.
on the other hand, I think if the interest rate is, I think, low,
Yeah.
the inflation is high.
Inflation should be high, but for some reason in Europe, inflation is still quite low. But you're right, it should be high. But unusually in Europe, it's quite low.
Because last year in the UK it was like deflation.
Yeah, exactly, yeah.
That's a big problem.
It is a big problem. Deflation and low interest means people won't really spend. Because if you know next year it will be cheaper, then why would you buy it this year? Yeah. Anyways, you can talk about that in economics. What are you doing in economics at the moment?
Functions of price.
Huh?
Functions of price.
Functions of price. Have you done inflation and interest yet? No. That's more macroeconomics, which is semester 2. I think right now it's microeconomics. Yeah, okay. Right, have a look at number 3. So I think now that you've seen 2 examples, I think what I'll have you do is I'll have you try number 3 now for a couple of minutes, and then I'll do it on the board. By the way, number 3 was like a recent exam question in the final exam.
Like chemistry questions. The
Hmm?
chemistry,
Yeah?
they use a lot of like
You're right, yeah, and in fact I have one of those there.
kind
If you're interested, that was number 5. So in the first part, what I'm asking you to do, in case anybody is unclear, is you're saying that the energy, yeah, I'm sorry, I didn't actually say it was energy, but maybe somebody knew that. Yeah, MW is what, yeah? Megawatts. So the energy used by a town is equal to AEKT. And I say that at the start of the year they use 12 megawatts, and at the end of the year they use 13 megawatts. Why might the town use more a year later? Why might that be? Any ideas?
growth again.
Yeah, well maybe there are more people living in the town. Or maybe tourists, or maybe people have more money. When people have more money, maybe they spend more, they use more electricity, they have more plasma TVs in the house turned on, they have more coffee machines making espressos all day. So there's many reasons why it might increase. So what I want you to do first is to find the A and the K.
How did you get this formula?
Yeah, the key word in the sentence is the energy is exponential. So if I said something is exponential, you can take this as a fact. The word exponential means this is the formula for it. If I said something was linear, that would mean this would be the formula for it. If it was a linear relationship. Yeah. So if you want to highlight it, it's the fact that I said it was exponential in part A. Have we got the A and the K? Great, okay. So let's do the first part. At the beginning, I said there were 12 megawatts used, and the T will be 0. So clearly the A equals 12. So that's fine. And then we know that at the end it was 13 megawatts. Now, what do you want to use for the T? Well, since...
Zero?
sorry, at the end.
One.
Yeah, both are fine. So if you use 1, then you have to keep using years, and if you use 365, then for the rest of the question you must keep using days. It doesn't matter. The people who use 365 and the people who use 1, they'll get different answers for the K, but both will be fine in the exam. So 1 is an easier number than 365, so I'll use 1. So it's just like what we did a few minutes ago. So after you divide by 12 and log both sides, you'll get K is 0.08. Now, the people who used 1, did you get that for K?
Yeah.
And the people who used 365, you should have a much smaller number for K. Yes. Right, so our answer for the first part is E equals 12E 0.08K. Okay, can you try the B part now? Or do you have that done? Yes. I don't know why I wrote K. Okay, try the B part. Or do you have the B part done? No, okay. I'm missing Pony, Remo, Junwei, and the fourth person. I think. Who? Oh yeah, Albertson. Okay, do we have the B part done? Oh look, in Oman, do you have interest on loans, or is it like Saudi? There's no interest.
Yeah, we have it.
You have interest, yeah. This is not like a problem. Like it's normal to have interest on savings and loans, and yeah. The Saudi students tell me that in Saudi there is no interest.
Uh, Actually, like, they have like some banks, they call it Islamic banks.
Yeah,
They give loans.
interest free, no interest.
It's uh, it's like another method, but they have interest.
Oh, I understand. Okay, so it's like having interest, but it's done a different way.
Yeah, they give them loans
Yeah.
with interest, but they don't call it interest.
Okay.
It's like selling you something in the future
Okay.
But you pay it now.
Okay. Okay. I understand. That's very interesting. Okay. Because when the students talk to me, it's like, no, no interest, no interest. But you're saying, well, really, it's like it's interest, but it's just called something different.
Yeah.
Yeah. Okay. Do you know what it's called?
Um, I don't know. What's like the interest is like for every year.
Yeah.
But this is like for the whole period of time. I don't
Oh,
know.
at the beginning or something.
Yeah.
Yeah. Okay. I understand. Oh, yeah. Saudi's having lots of financial trouble at the moment.
Mhm.
Uh,
It's all about
the
oil prices.
oil prices is really cheap. What's it like? $35 a barrel?
In the 20s now.
It's in the twenties now. Yeah. A serious cash flow problem. Yes.
Yeah.
Yes. Okay. Well, it's good for the rest of us. It means it's cheaper for me to fill up my car. Yes.
That's right.
Not good for Saudi. Good for me though. Okay. Have we got the B part done? Yeah. No? I thought the B part was easier than the A part. Yeah. So in the B part, what I'm saying is that the energy and time, that they're linear. So it's like a problem you did in the first week. This is 0, 12, and this here is 1, 13. And the equation of a line, y, equals mx, which is t, plus c. Now you know how to find the m, don't you? The formula. So what's the m here? 13 minus 12 over 1 minus 0. So that is 1. So I have E equals 1t plus c. And how do you find the c? Yeah, use a point. We'll use this one, okay, because it's easier. So you have 12 equals c, because the t is 0. So E equals t plus 12. Okay, so write that one down. Let's have a look at the graphs now. Yeah? Can I just switch the graph? Okay, can somebody just tell me what was the formula when it was exponential? It was 12 e power 0.08 t. Okay. Now we'll have the graph starting. There. So at the beginning you can see that the energy the town used was 12, and then 1 year later it increases a little bit to 13. Actually, let me just pull the graph down a bit more. Whoops. There we go. So the energy is slowly increasing. Now, what about the second graph when you said that the energy increase was linear? Well, that was t plus 12. So let's see what graph you get here. Now, do you see, of course, that the graphs are different because they're two different formulas. But it's not surprising that the red graph is higher than the blue graph, because exponential means the graph goes very quickly up. Whereas linear, the blue one, is just nice and straight. What I want to know for the next part is what's the difference between the red and the blue line if you use them to calculate the energy after 2 years, they won't be the same, they'll be slightly different. And you can notice that after 7 years, the difference between the two formulas is more clear, bigger difference. So what we'll do, we'll use the two formulas and we'll put T equals 2 into that formula and T equals 2 into that formula, and then let's see what we get. Well, this one's easy. It'll be 14. And the other one, let's see. It will be 14.08. So the difference is 0.08.
But this is only for a particular time.
Yeah, and as the time increases, the difference becomes even greater. Yeah.
So I think it's better if you like second semester use integration.
Oh yeah. That will come in time. Don't worry. Which model do you feel is more accurate, the linear model or the exponential model?
Exponential.
Good. Why?
It's like the supply and demand. It doesn't like seem to be linear or something.
Oh, the supply demand curves, they kind of go
Yeah.
up like this, do they? Yeah. You're right. Most things in life, it's a curve growth. Now, it's not really exponential though. In real life, what will happen is it will increase, but it won't increase like this forever. What will happen later?
Decrease.
Well, maybe a decrease if there's a downturn, economic crash. But usually what will happen with a town is they'll increase their energy usage until the town reaches a maximum size, and then the energy will start to level off. But it could decrease if the town becomes more efficient, better light bulbs, things like this. So it might drop a little bit, something like this. So you can say that, okay, for this part of the graph, you can say it's exponential. Maybe for this part of the graph, you could say it's linear, things like this. This is a little bit more advanced than what we need for the exam, but everybody had the right idea. The exponential is the one that's probably more accurate. The same when you look at population. Population usually increases like this, unless something happens, such as a one-child policy, then maybe it'll go down. Okay. Or if you're talking about Saudi Arabia, they discover oil, then the population goes up. So it's, for most of the time, it's a simple graph, but of course life is not simple. Okay, these are questions you could get in the exam, and in fact the question I just did was very similar to an exam question. So it is important that you do try to do all of these, okay? There are not too many, and we already did 3 of them. So if you can try and do the rest of them, okay? Alright, we'll leave it there.